So quick reminder, homework 1 due today. The HTML, CSS, JavaScript static site. A week from today, after today's content, you'll have everything you need to solve homework 2 to develop that. A week from today, homework 2. This will be the rhythm of the class. Each week, there's a homework associated with that week. This week is homework 2. This is where I show you everything you need to be able to do homework 2. And the following week on Friday, that's when that homework is due. So last week we did all that, the front end stuff, and then you have a week to process, digest, and study all that material to do the homework. And this week, cover all the HTTP stuff, then you have a week to digest, study, and everything, and do that homework. So that'd be the theme of the course, except for the first week, obviously nothing due, and then 3 of those weeks there will be project submissions. But it'll be 10 homeworks, 3 projects. Just a reminder of how the course flows. Yes?
We get feedback on our correspondence, right? We got reports of that.
Will you get the results of those?
The feedback already.
So it might not necessarily be feedback, but you will get your grade within a week. So we had the self-grading report forms. If the TA and I don't grade your assignment before 1 week after it's due, so the due date of the next homework, your grade will be what you self-reported. So you'll at least get your grade guaranteed either at the next homework deadline. If you get feedback, it will be before that deadline. And then after the next homework's due, we're going to start grading the next homework. So that's the idea of the self-grading, to guarantee that you do get your at least grade before that. And if we don't get to your homework and you revert to that self-reported grade, feel free to come to office hours and we can go through your assignment and talk to you about it, and you can get that feedback if you want that feedback as well.
Yeah, I was sure about the write-up.
Sorry, what was that?
I was sure about the write-up.
Right. Oh, right. For homework 1, I assume we'll be able to get through them all. Those will be pretty quick to grade, so we'll get some feedback on the write-ups too. The write-up for homework 1 really isn't that involved. It's, okay, go to the browser, or open this file in the browser and then click around and stuff. Homework 1 was mostly to show you what the homework submissions are like. There's a zip file, a text file, and a self-reported form. Just making sure we get all the logistics of that done. Homework itself isn't too complicated. Posting can cause some issues at some points, but the technical content is much. So I'm just showing you, okay, how do we submit a homework? For homework 2, that's when the write-up is going to be more important. So we'll really try to get feedback on the homework 2 documentation. And we'll be understanding for this class. If we don't give you feedback on that and revert to your self-grading, and then you make the same mistake on homework 3, we'll understand. Like, unless it's clear that you're not putting in any effort. Like, if there's some content there, it's just not quite what we're looking for, we'll be understanding this class. Yes.
Quick AI question. I'm having problems setting up my environment. I'm assuming it's okay for me to look on like Stack Overflow, that kind of thing, get the environment running, as long as there's code in there trying to play with that.
Yeah, absolutely. So the question is, in terms of AI, is it okay to look up online resources to get your environment set up? So getting libraries linked and all that stuff. Yeah, absolutely. As long as it's not the technical content of the course. So the measuring stick you can use for that is it something that I'm trying to get you to understand through this course? Is it something you're learning through this course? I never mentioned anything about environment setup. With TCP, I'm just like, yeah, go get a library or whatever. I didn't really talk about that. That's not really content of this course, so that's fair game. Whatever you got to do to get your environment set up, get your TCP library set up, get your TCP socket server set up. None of that is stuff that I've covered in the course, so that's all fair game. Just do what you got to do to get it up and running. When it comes to HTTP, I'm going to talk about parsing HTTP headers and everything. That is something I'm explaining in the course, so that is not fair game for AI, whatever way to word that. If you're getting an online resource that parses HTTP headers for you, that's not okay. That's something I can go after you for, and that I will be looking for. But anything that I didn't explicitly cover in the content in the course, with TCP, IP, I just went over a high-level overview. I didn't get into any technical details. I didn't say how to code that 3-way handshake or any of the actual protocol details for that. So that you can use libraries for and go with. Any actual content, parsing HTTP requests, that I'm looking for AI on. That's because that's what you're here to learn is the HTTP stuff. All right, any other questions? All right, let's get into it. So last time we were doing HTTP overview. Let's do the rest of this overview. I just had a few slides I didn't quite get to. So let's finish up the overview. And then most of today we're going to talk about the specifics of getting an HTTP request and serving an HTTP response to the user. So these are our formats of a request. I'm going to gloss over the overview slides really quick because we're going to go in detail on this in the next slides. But we have a request line, any number of headers, and then the body of the request, the actual content that we're sending. If it's a GET request, we're not going to have any body to the request. If it's a POST, we'll have some information that the user is sending to us. We won't worry about POST until, oh my goodness, 2 weeks from now? That seems so late, but yeah, I think POST we don't even talk about next week. But POST, we'll get to that. So for now, all of our HTTP requests won't have a body until a few weeks from now, till after next week. And content length, again, we'll talk about this a little bit more, but the content length is how much information should be read from the body. How large is this, is the content of this request? Then the response is the server taking that request, parsing it, and serving up whatever content is needed for that response. The response has a response line. Again, this is stuff we'll talk about in a little bit more detail in today's slides, so I don't really need to focus on the overview slides too much, but we have a response line given the general status of the response, the content type and length giving us some meta information about how the browser should read the response, and the response itself in the body of the response. We have response codes associated with the response. Some of these probably look familiar, some of them maybe not so much. The most common one, which might not look familiar to you, is 200 OK, which we'll see all the time in this class. 200 OK, a 200 response code means you requested something, the server responded, and everything went great. The reason you don't see this very often is because you're usually looking at the web page you requested. You don't really have to see this because it meant everything went right. You're just browsing the internet as usual. So you're not going to see these unless you open up your browser console and look at the responses. Usually you're just navigating the internet as usual if this happened. Move permanently and not modified. These you won't really see either as a user from the user perspective. Of course, 301 you're going to write in your homework. This means that there's nothing to serve at the path that was requested. So there's no content that needs to be delivered. This can have a few different things. For example, 301 is a redirect. There's nothing to see here. Go over here. This is what you're looking for. Or 304, not modified. Hey, there is something to see here, but you already have it. And this 304 is important for caching. If it's a cached file, the user is going to give a timestamp and say, hey, I have this file. It's cached. Here's the timestamp of my cached file. And if the server looks at that cache date and says, well, I haven't changed the file since then, I'm going to send you a 304 and say, I'm not going to bother sending this to you because you already have the latest version of that file. This is really important to reduce redundant traffic. To be sending the same files over and over would increase a little congestion, be too much load on the server, on the user, load times are going to increase and everything. So we have our 304 for caching. Forbidden, these are getting into the ones that you will see because it means your content wasn't served. Forbidden means you went to a page, a resource, you requested a resource that you don't have permission to access. This, a lot of you saw this, at least in Office Hours, I saw a lot of cabinet. In the posting of your homework 1, if you don't set your permissions, if you're using the CSE server and you don't change your permissions to 755, you don't do change mod 755 on your files and on your public HTML folder, your directory, you'll get this 403 because the web server tries to access your directory, but you never gave it permission. You never gave the CSE web server access to your files. You never said it had permission. So the web server says, I don't have permission to access those files, so then it gives you the 403 and says, you don't have permission, you can't access those, you're not allowed. You have to go in, change that mod to 755, which means anybody can read or execute those files so that web server can read them and serve them to the end user. So this one you might, many of you have seen in your homework. So that means you don't have access. And then 404, of course, part of homework 2. And the notorious, I'm sure you've seen this plenty of times, you request something that doesn't exist. If you go to a path or a resource that the server just doesn't have any content for, it's not one of the paths that that server's expecting, you're going to get hit with the 404. It's going to say, I got nothing for you on this. And usually give you some HTML, some splash page that says, hey, that content wasn't found. Maybe adjust what you're doing. And then 500. This is the scariest one for any web developer. This means the user did everything fine, the user is okay, but something crashed on the server side. So that means our server had some error that it couldn't handle, it crashed or whatever. Something happened where the server wasn't able to handle that request. We don't have full fault tolerance in our server. We're going to send that a 500, and the user's kind of screwed because it wasn't their fault. And this is when developers get the early morning emails or phone calls and say, hey, the server's crashing, what are we going to do? You panic, you try to get a patch out real quick, you try to get things up and running. You see 500 errors in production. It's the stuff of nightmares for web developers. And, oh, right. This one I do want to talk about a little bit.
Yes, 500 error gets served automatically. So I'm assuming the server's just not working, something that's not that error.
So the 500 error does not get sent automatically. In most web frameworks, it will send the 500 error, but you would have to catch, like whenever an exception is thrown in your code, you would have to have on the top level of your web server a big try catch, and in that catch, you would send the 500 response. That's something we would have to code. I don't have plans on doing that to our web server. I guess it would be good practice to do that, to wrap everything in a big try catch. Maybe that should be part of one of these things. I don't know where we're going to go. But that's how you would do it. If we don't do it in class, that's how you do it. You catch any exceptions that are thrown and then respond with the 500. Say, something went wrong. I don't know what. We're going to fix it, though. All right, this one I do want to talk about a little bit because we're not going to talk about this one again. I want to talk about it in the overview because we won't talk about this again until after spring break. I believe a few weeks after spring break. It's going to be a while before we get back to this. But HTTP is a stateless protocol, meaning the server, our servers that we write, have no mention of state. Anywhere in your server, you're not going to say, okay, I got an HTTP request, and then pull up the state of some connection and say, this user that just sent this request also just sent this other request, so let me handle this in a special way. For example, if a user says, hey, give me your HTML file, they read that HTML file and then say, whoa, this HTML says I need some CSS and JavaScript. So they send a request for the CSS. When you get that CSS request, you're treating that as a completely independent request from the HTTP request. You're not saying, whoa, it's the same user that just requested the HTTP. You're also not saying, when they request the HTTP, you're not like, oh, you're going to need these other files, let me give them all to you. There's nothing like this. A web server on each path for each request is treating it in complete isolation. There's no state for this. As opposed to TCP, like TCP has this connection and a state, and there's multiple packets across this one connection. With HTTP, there's just one request, one response per connection. There are later, more cutting-edge versions of HTTP, which will kind of have a pseudo connection attached to it. We won't go into those in this class, but there are newer versions of HTTP which don't create a new TCP connection for each request. It sounds wrong as soon as I say it. Do I go into all that? So HTTP, the one that we'll use, will reuse the same TCP connection, but won't have any state attached to it. Let me leave it at that. So if we need state, if we want state, there's something extra we'll have to do. We have to do more things to be able to simulate the state. And that's where we have cookies, and those cookies are going to store tokens. So for example, whenever I log into a site, whenever I do something on that site, I don't want to have to re-authenticate every single time. If I want to send a message after logging into somebody, I don't want to have to type in my username and password each time. Every time I update my news feed, I don't want to re-enter my username and password each time. We'd be doing nothing but re-entering our username and password. So we do want the sense of state. We want the effectiveness of a state, but we can't actually get that through the protocol itself, so we're going to have to do a little bit extra. So for authentication, when you type in your username and password, the server is going to give you an authentication token. It's going to give that as a cookie, which means it's going to be sent in the headers of every subsequent HTTP request. So every request after the authentication request is going to have that authentication token attached to it. Then the web server is going to look at that token, look up your information in the database, verify that that is a valid token that was signed, check the user account attached to that token, and then say, okay, if you have this token, which should be nearly impossible to guess, if you have this token, you must actually be the person you claim to be, and at some previous time, the server won't remember or care, but it'll think, okay, at some previous time, I myself, the web server, must have given you this token because you're in my database and everything checks out. So every time you visit that site again, you send that token, the server reads that token, and then you're able to stay logged in without having to retype your credentials. This will work until you either clear your cookies, use a different web browser. If you switch from Firefox to Chrome, you're going to have to re-authenticate in all your sites because Chrome can't steal Firefox's cookies. Or if you manually log off, or if that cookie expires. Cookies have expiration dates. Most authentication cookies, I believe these days, they are either no expiration date or at least very long expiration dates. There's some sites I visit where I typed in my password a long time ago, feels like years, and I haven't had to re-authenticate yet. I just type in my username and password once when I create that account, and I just never get asked for my username and password again because that token is still there in the cookie. Yes?
Could you also put authentication tokens in the header? Is that
Yes. Yes, so actually we'll talk about this at length next week, but the cookies actually are a header field. There's a header field cookies, and that stores all of your key value pairs for your cookies. But they all go in one header field and are separated by delimiters. But yeah, cookies, that's exactly how they work is through the headers. There will be a set cookie header, and then the cookie value, and then after that is set, both the server and the client are going to send those cookies back and forth.
So one's not more secure than the other? Or they got
Between headers and cookies?
Yeah.
So the cookies work through headers. If you were doing it with headers without using cookies, you would be rebuilding the functionality of cookies to an extent. Okay. Any other questions before we get into today's content proper? Okay, so that was really an overview of HTTP yesterday and this beginning of today, cleaning up those slides. Just what is HTTP at a kind of high level. Now we want to focus in and say, okay, that's great, but I got this homework due next Friday. How do I actually do the homework? That's what we want to talk about today. Today's homework is just next week's homework 2, I'll just say homework 2, is all about getting this request response behavior out of HTTP. So we don't really want to serve anything complicated. We're just serving effectively hello world and then a redirect and a 404. But we want to get this request response pattern down. How do we get a request, serve a response? How do we actually do that? So whenever you have questions about HTTP, the de facto resource is the RFC, RFC 2616. This defines everything that is HTTP. Any question you have, The answer is here. It's a lot of documentation, there's a lot there, but your answer will be in there somewhere. Today, we're really focused on sections 4, 5, and 6 of this. I guess 7 to an extent. But 4, 5, and 6 are going to define the formatting of requests and response in general HTTP messages. Section 4 is the structure of an HTTP message. 5 is the specific structure concerning requests, and then 6 is the specific structure concerning responses. If you follow these structures and the syntax and formatting exactly, two programs that both speak HTTP, if you're following that format, they'll be able to read and parse messages written by the other. So if we follow that formatting, the browsers are going to be able to read our responses, and we're going to be able to read their requests because they're going to follow the formatting in section 5. We'll follow the formatting in section 6 in our responses, and then everybody's happy, everybody's reading the same documentation, everybody's following the same protocol, the same standards. We'll be able to be effective, write effective web servers. RFC stands for Request for Comments. This is, people can submit these RFCs to the community, submit an RFC, and then have public discussions about those RFCs, whatever they're, whether they're proposing a new standard, or whether they just want to give some information. They'll submit a request for comments. This isn't even on. What am I doing here? Oh, everyone can hear me fine, right? Let me just not use this. This is small enough of a room.
But different people on the picture,
Yeah, I'm using my laptop
okay.
mic for that. That's why I stand over here. I like to pace during lecture. I'll usually pace back and forth, but I gotta stay by my laptop because I'm using my mic, my laptop mic for Twitch. And then the IETF, this is one organization that will accept requests for comments, and requests for comments specifically about the internet and about new RFCs about the internet. They will sometimes take an RFC, there's good community support, there's good discussion, it seems legit, like it's going to be a good thing moving forward. They'll take some of these RFCs and convert them into internet standards. They'll say, okay, RFC 2616, the community seems to really like this. Everybody seems to be in agreement that this is a good standard, that this is how we should send requests and responses over the internet when we're communicating hypertext. Let's use this as the standard and say this is what everybody should do. So they'll promote some of these RFCs to internet standards. There's a pretty loose organization here. There's nothing too official about this, but this is the closest thing we have to a standards agency related to the internet. This is the closest we can get, and it's working pretty good for us. I think for the most part, everybody's pretty happy. But for example, there's no government affiliation with this. There used to be, but in the mid-90s, for whatever reason, I don't know the exact reason, but the government stopped supporting this. And now it's just some independent group with loose organizational structure. If you wanted to be part of the IEFT and you kind of knew what you were talking about, and they're like, you seem legit, they probably just let you be part of it and start doing work for it. It's a very loose organization. There's no central force saying, I am the internet, which is kind of, I feel like it kind of should be that way with the internet. That is kind of the way the internet goes. It's just a very loose organization of a bunch of people doing different things, and it all kind of comes together to this big thing that we know of as the internet. So it's kind of fitting that the standards themselves defining the internet work the same way. It's just kind of a loose structure of a bunch of people saying, this seems like a good idea, until eventually a bunch of people say, let's make it a standard. So nothing crazy here. It's a bunch of people saying what the standard should be. Yes?
Aren't the standards also partially defined, by the, major browsers? If they change something, they mostly follow this, but.
Yeah, absolutely. So the major browsers do have a lot of influence here, but they have influence just as community members.
Oh.
So like the Chrome developers, they'll submit RFCs, but they're just part of this larger internet community. So the browsers definitely have a lot of influence. Google developers, I briefly mentioned newer cutting-edge standards for versions of HTTP, HTTP 2 and Quick. These are developed by Chrome and Google engineers. And then they said, hey, let's share this with the world, mostly because they want to use those technologies. And if the other browsers don't adopt those technologies, well, not only Chrome users, things like that. But it's all one big community working together to get this working. A lot of those community members are employees at the major tech companies. All right, this is kind of a side note, and but it applies to everything we'll talk about here. New lines in HTTP are technically defined as a carriage return and a new line character, the /r/n. This is kind of a relic from the past. It comes from the days of typewriters. With a typewriter, you get to the end of a line. You have to take the carriage and return it, carriage return back to the start of a line, and then move the carriage down one line. So it was two actions. It was a carriage return and a line feed. So this terminology will creep up in the documentation all the time. If you see CRLF in the documentation, you can read this as a new line, but it means carriage return and line feed, just from the old days when computers were first becoming a thing. Well, typewriters were the most the dominant form of writing and typing, I guess, at least, which we can see in our keyboards too. The keyboards are made off of typewriters as well. Any unused, seldom used characters are towards the edges. Anyway, so the naming and the characters were from the old typewriter days. The documentation in the RFC says that we can usually use just a new line character. If you're using just new line characters and you're running into some strange errors, especially on browsers, especially if you're using an older version of a browser, try changing that to /r/n. It might help, it might not. The standard recommends that you take either. If you just have a new line character, that the browsers and our servers should be able to handle either. So just be aware of that. And also, if you're getting requests and you're just splitting the lines on the new line character and you're getting some really strange errors, just try. It's one thing to check. Maybe the browser is sending you requests with a carriage return and a new line character. One quick fix: when you get a request, replace all carriage returns with the empty string, and then just treat everything as new lines. There's technically some situations where you might get in trouble. There are some really old software that will just use a carriage return instead of just a line feed, just a new line. So just some things to look out for if you're running into really weird bugs. I did some testing on with my browsers. Everything was just working off of new line characters, but if I send either new lines or carriage return new lines, they were working with both of those as well. So your mileage may vary, just be aware. It'll depend on your versions of browsers and everything, what libraries you're using, and it's not really the libraries you're using, but the browsers you're using and the versions of those browsers might be using the old style of requiring CRLFs. And if you see this in the documentation, that's the other key point. If you see this in the documentation, you can read that as new line. Okay, so we get a request, we got our TCP socket server running, and we get a request. We get a connection, the three-way handshake happens behind the scenes, and we get our first request. What do we do? How do we parse this request? So let's look at a very, very simple request, this one right here, and parse through this and look at what each piece of this means and what the formatting is going to be. So what do we do when we get a request? We have a client connecting to our TCP socket server and sending a request for a specific resource. What do we do? So first, every request is going to start with what's called the request line. This is always going to be the first line of the request, and it's always going to have these three parts, and these three parts are going to be separated by spaces. So when you start homework 2, if you haven't started it yet, you're going to notice that most of this homework and a lot of what we do is going to be string parsing. You get this message as a string. How do I get the information out of it? So the message will be multiple lines. So we want to split on those new lines or carriage return new lines, so carriage return line feeds. We want to split. I'll just say new line from now on just because it's easier. And you can usually get away with that anyway. But we want to split on new lines to get the separate lines of the request, and then take that first line and look for the spaces to get the key pieces of information out of it. These 3 pieces of information are the request type. Is this a GET or a POST or a PUT or a DELETE? What type of HTTP request is this? This week and next week, we're just going to focus on GET, and then the following week we'll see some POST requests. So we're going to see the request type. The second value is going to be the path requested. This is, if we recall from the URLs last time, everything after the server name and port. So if we have localhost colon 8000, everything after that is going to be the path that's put in this request. This can include query strings. It'll include fragments if they exist. We'll worry about that when we get to those. When we get to those next week. But that'll have the whole path, that whole part of the URL after the server name and port, the IP and port, or domain name. We're using domain names. And then the third part is going to be the HTTP version. For this course, we're going to stick with HTTP 1.1. We actually have there is a course in the discussions of being proposed. I don't know when we might be able to get this one on the books and offer. But there is a course that we're talking about that would cover the more cutting edge HTTP protocols and talk about scaling up and efficiency and stuff. So it's possible we will have a course that will cover that. For this course, I'm going to stop at 1.1. I'll only talk about that, and then hopefully we get that course on the book someday. So this will be my stopping point, and then that course will pick up the rest of the stuff.
Sorry, it's more of an implementation question, but is it okay if we use regular expressions when we're parsing our strings?
Absolutely. So the question for Twitch, can you use regex for parsing strings? Absolutely.
Okay.
I don't think you'll have to, maybe when we get to the more trickier, more complicated string parsing, but it can certainly help. It can certainly clean up your code. Highly recommend it.
And the other annoying question is, what's the encoding of this? ASCII, Unicode,
Of the
header?
header.
This request.
That's a good question. I'll get back to you on that one. Because we'll see starting Monday, we will put the encodings as a header field. But how do you read that header? How do you know the encoding of the header? I would assume that the browser will assume Unicode, UTF-8.
Sorry.
I'm not sure on that. I was thinking the same thing. I was reading some resources the other day. When we put UTF-8 in our HTML and say, hey, browser, render this using UTF-8, and somebody's like, well, how does the browser read that UTF-8 if it doesn't know the encoding yet? Yeah, same question, like how does it know? And I don't think there was a solid answer on that one either. I think somebody's like, oh yeah, the browser will just assume until it gets to that part. I would guess it would be the same thing here. Yeah, what if you have some weird encoding for your response itself? I guess nobody can visit your webpage. Would be my actual guess. We'll always use HTTP 1.1. If you want to ignore this third value in this course, I'm not going to blame you. I'm not going to come after you or anything. You can just assume that's HTTP 1.1. But the first 2 values, the request type and the path, these we have to be concerned about. We have to be able to route our requests based on these 2 pieces of information. So if we have a GET request for / our home directory, if we get a request for /, this is the root of our web page. This is usually where you're serving up your home page. If somebody just types in your domain name, you want to serve up your home page. You're going to get that request for / and do something with that. We're actually not using that for homework 2, but we will start using that. And if you build a page, that's where you want to host your stuff. Most web servers, if you request for / web servers, web frameworks, whatever you're using to build your sites, that slash, it's going to look specifically for index.html. That's just a standard that that some developers decided to use. That hey, let's name our root HTML index.html and serve that at the slash that root path. Yeah.
So I just want to clarify, is just the slash the path, or the HTTP is part of the path as well?
Just the slash. So just this slash is the path, and then the HTTP version is associated with each request.
So is there a rule that there has to be one space between the HTTP and the
Yes. Yep. So there has to be one space. So we're going to look for those two space characters, this space right here and this space right here, or this space right here and this space right here. But in our code, when we parse this request, we're looking for those. We're taking the first line, cutting this up by lines, take the first line, look for those two space characters, and separate the values we're looking for based on the locations of those two spaces. So that's the standard. That's why with the documentation, the standard of HTTP, that's how we're able to use HTTP. That's one of the parts of the protocol. You separate these values by single spaces, and now when we get a request, we know that the browser, if they're speaking HTTP properly, they're going to have those two spaces, and we can figure out exactly where the path is and read that path. So index.html, if you're wondering about that, that's just a convention. That's not part of the standards, not part of really anything. But the first web servers, I believe Apache popularized this when they developed Apache. They said, look, if somebody just requests slash, we're not just going to serve up nothing or whatever. Let's just tell our users to name their file index.html, and then in the web server software, it says, look for a file named index.html and serve that if it exists. So no magic on that one, but that's why we name those index.html. It's just the way they built those web servers. Apache specifically, I believe Nginx adopted that as well, if I'm not mistaken. It just kind of became a pseudo standard. We follow it, but it's not part of any standard. And then the URL can contain a different path. If that path is different, if somebody in their URL, in their address bar, typed /lecture or /whatever, or clicked a link that has a different path, this is where that path is going to show up. And this is how we can route our requests to different paths. So in our server, we would have if request type equals get after parsing everything, and then if the path equals /, do this. If the path equals /lecture, do this, etc. And if you've developed with web frameworks before, this is usually your first thing that you do. Very first thing, the web server has all the string parsing set up for you. And then it'll say, okay, just tell me request type and path, and then give me some code. I'm going to run that code when I get a request of that type on that path. So if you run, first set up in a server using a framework, you'll have like server dot on a get request and then a string for the path. Do this code, call this function, do this stuff. So if you ever used a framework, this is where they would start. They would do all this parsing for you behind the scenes, and you're just telling it how to route, what routes to pay attention to when they get a request. The request line is followed by any number of headers. These headers, only one in this for this example, but any number of headers in key value pairs with one per line. There can be, technically, I haven't seen this in the wild yet, but there can be headers that key value pairs in the header as a header that span multiple lines. I haven't seen that in the wild, so we're not going to worry about it unless it comes up explicitly. But we're going to get these headers, key value pairs separated by a colon. And you can have white space here. Most browsers are going to ignore this. Technically, it shouldn't be there, but I think most browsers will remove leading and trailing white space. If you run into issues with that, get rid of your white space. For the response anyway, for the request, I think they usually have that white space there. If you get this white space in your request, good habit to trim leading and trailing white space in each of your header fields to be able to address that change. But each line is going to have a separate key value pair until you reach blank line, that's when you're done with the headers, and you're done with that request. Now we need to send a response to the user. Once we parse that, we're going to write a response and then send this response over the TCP socket. Most libraries are going to have some function, usually named write this value back over the TCP connection, that whatever connection sent me this request, let's send back to them, right back to that TCP socket, my response to them. So with this response, we have similar formatting, but a little bit different. First, the status line. This is the first line of any response. So this is the first thing you need to add to your response when you're sending a message back to a client. This is going to contain 3 values. The HTTP version, which is the first value instead of the third value, because I don't know why, they have to be different. But the HTTP version, again, you can assume we're always using HTTP 1.1, so every one of your responses should start with HTTP/1.1. 3 values separated by spaces again. The next value is the response code, giving some meta information about this response to the browser. What is this? What should they look for? What happened here? Here we're using 200, which is just the OK, and then another space in the status message, which is more of a human readable description of that status code, whereas the 200 is more just machine readable until you start to memorize all the codes, then it becomes developer readable as well. This is followed by the headers. These are in the same format as the request. We have our response line, and then key value pairs, 1 per line, separated by colons, all the same formatting. Rules apply to these headers as they did for the request headers. We need at least 2 headers, the content type and content length. Content type we'll talk about in more depth on Monday. For now, for this homework, all of the responses can be text/plain. We're just serving up plain text to the user. When we start serving up HTML, this would be text/HTML, and so forth. We'd have, that's wrong. Yeah, we'll talk about it Monday. I don't know. It's not text, it's something, maybe it is text. I don't know. But I'm blanking off the top of my head. But there's an encoding, or a content type for HTML. This is what we call MIME types. We'll talk about as we get to that. And then the content length, how much information should be read from the body. The browser will use these to figure out how much to read. If this content length doesn't match the length of your message, you might get some errors in the browser. For example, if this was 2, the browser is only going to read the first 2 characters here and just write he to the screen. We don't want that. We want our content length matching the actual length of our content. And finally, the body of our response. After the headers are going to be followed by 2 new line characters. So we're going to have this empty line here. Once we have that empty line, that's us telling the browser, hey, the body of the response is about to start. And the body contains all of the actual content that's being served by our server. So our server served up this content that just says hello, and that 5 not always characters, but 5 I'll say pieces of information for now. Pieces of information are going to be read from the content. So we're going to read hello, and that's what the browser will display. And when we get to post requests, the requests are going to have bodies as well. So we'll have to read all the headers, look for a blank line, and then after the blank line, we're going to read this amount of information, the content length amount of information from that body of the request. I'll talk a little bit more about response codes. These, the code itself, as I mentioned, these are read by the browser to figure out how to handle this request, if there's anything special that needs to be done, and gives the browser some information. 200, everything went great. 404, didn't find the information you were looking for. And then a human readable message, okay, for the 200. And each code here does have kind of a standard by convention, and in the documentation, the RFC, there is a message associated with each error code, or not error code, each response code, but these can be different. These aren't hard and fast rules. If I put something other than OK here, everything's going to work fine, and the browser's just going to display a different message to the user. It's going to say whatever I type here, that's what the browser is going to say. Well, not necessarily to the user, but in the browser console, you'll be able to see that message. But this, you don't have to be too strict about following the conventions, but it's always a good idea, of course. And some response codes don't have bodies to the, oh, sorry.
I was just gonna ask for the human readable portion of that line.
Mm-hmm.
What if it's like 2 words and you need to put them spaces, will that mess anything up? Like not-
No, but that's a good question. I don't know exactly how the browser handles that. Because when we have not found here, the browser will display not found. So it must, after the second space, the browser just takes everything left on that line and sends it. Because the spaces don't mess with that. Yeah, I didn't think of that. There definitely can't be spaces in these first 2 values, but yeah, it must look for the second space and read everything after that. And then some response codes don't have bodies associated with them. For example, your 404 does still have a body attached to it. Usually this is serving up some HTML that's going to show the 404 error page. For our purposes, for the homework right now, we're not going to worry about HTML yet. We're just going to serve plain text, but you can give some plain text message. You can just say the not found or whatever. But that will have a body. It will be in the same general format as a 200 response, but it's just indicating that your stuff wasn't found and you're giving them your 404 page. 301, on the other hand, does not have a body. There's no content type, there's no content link, there's no content to read, there's no body at all. This is just going to be a redirect, and when a browser sees a 301, oh man, I left my OK. You know, I saw that earlier and I still didn't fix it. That should be 301 moved permanently, should be the message here. And then when the browser reads this 301, it's going to look for a specific header, specifically named location. It's going to read that location and then redirect to that new location. This location can be a relative path like I have here. I'm just redirecting to the root, back to my home page and saying go back to the root path. When it's relative like this, it's going to redirect to the same server, the same IP port pair, and request the new path. I'm just saying make another request to the same server on this path, or it can be an absolute path. So if I want to say location https://buffalo.edu, I can do that and redirect them off-site somewhere if I want to have that kind of redirect. But the location is going to say, 301 says redirect, and the location says this is where you should redirect to. Make another HTTP request for this new resource. And that's it. We got caught up on our slides. All right. With that, I'll have a good weekend. I'll see you Monday.